Manufacturing Podcast. We are powered by the Precision Metal Forming Association. We're glad to have them sponsor and handle all the technology behind the scenes of the podcast. I am your host, Dean Phillips, and I am so proud to be here with you today because I have with me from Grace Technologies their CEO, Drew Allen. Welcome, Drew.
Thank you, Dean. Thanks for having me on. I appreciate it.
It is so incredible to have you on here and to talk about the future of technology. The
future is definitely one of my favorite topics. So I'm excited to dive in today.
I love it. Especially with somebody like yourself that understands and is looking always to the future of technologies. It's great to have you here. So right off the bat, what is your big takeaway for the future?
My biggest takeaway for the future is I think that these fully autonomous factories, these so-called dark facilities, are going to be coming online a lot faster than we think. Ultimately, the intersection of low-cost robotics, design for manufacturability, 3D modeling, and IIoT are going to just make the need for humans in these facilities a lot less required. I think that there's a lot of important aspects to that, especially the kind of cultures that we're putting into place in these facilities, the engineering teams that are required to design and build these facilities, as well as how we go about thinking about manufacturing different products. I'm a firm believer that we don't necessarily need to invent the future. We just have to find it. It's already here. And I believe that, whether the future is, there's a dill pickle facility not far from here that's been a dark facility for years, right? Before it was cool, right? Now we're hearing also about a lot more dark facilities coming online in China. I was also sharing earlier as we were warming up on data centers and how, a $750 million data center is going to employ, a few dozen people. These are really important trends, and I'm not sure that we're quite prepared as a society, as well as business leaders, of how dramatic this kind of effect is going to take hold over the next 5 years.
Yeah, I couldn't agree with you more. I think when I look at what drove some of the decision making for technology like robots, two things that were always impactful for that. One was weight. It was too difficult for a human to lift and manipulate perhaps a car body into the right position to weld it. That was one of the considerations. The second consideration was always safety. And if it was a high risk location or something where somebody might be injured more frequently, that we would start looking at robotics. What do you see today that is driving technology, not specifically towards things that were out of scale for somebody to handle or that was unsafe for them to handle? Where do you see the robotics trend or automation as a whole?
Well, while I feel like this is a bit of a dead horse, I'm going to continue to beat it. Look, the workforce changes that have happened over the last 5 years are really, really dramatic. And we're not just losing the factory floor worker who's been working on this machine for the last 25 years. We're losing the engineer who designed it at the OEM. We're losing the engineer at the large electronic manufacturer, the Rockwells, the Siemens, the ABBs, that designed the drive that goes into the machine that now the guy on the factory floor has to maintain. We're losing a very large subset of kind of technology expertise and a way of thinking about things. And so it kind of shakes the Etch-a-Sketch a bit. We kind of get to have a clean slate now of like, well, if your company's lost all this talent, how are we going to manage this? And so oftentimes it's easier to do one large jump than just a bunch of small incremental changes when you've gone through this massive labor shift. And I think that that's been driving a significant amount of a significant amount of change. I think in a lot of the greenfield applications, the scale that we're seeing is also quite different than what it has been in the past. The U.S. isn't making facilities um, currently like we were making 10 or 15 years ago. I mean, the amount of greenfield facilities 15 years ago is minuscule. And what was being built were not anything to really write home about. But now we're building facilities that make, the 1960s and 1970s look, quaint. I mean, not just choosing data centers, but I mean the CHIPS Act,
Yeah.
I mean, these facilities, the stuff that's coming out of Tesla and the giga facilities. I mean, the power draws, the scale is so large because the only way that you can really continue to innovate is to drive massive scale, which really drops the price.
Mhm.
And I think that a lot of folks have looked at guys like Elon and understand that in order to really get ahead in the manufacturing game, scale is the most important. And you can't go and hire 100,000 people. It's not feasible in the US.
Right.
And apparently it's not even feasible in China. I'm not exactly sure where it would be feasible at all currently, maybe India, but that's about it.
Yeah. Well, it's interesting you say that because I think people like to point to China and say that the reason that they're competitive or the reason that they have their success in manufacturing is because of cheap labor. But if they're looking at automation, you can be assured that it isn't just about labor costs, isn't the only thing. If they could throw another 1,000 people at it, I'm sure that they would. So they have to be seeing a value in automating. So let's look at that for a minute. What are some of the things that you see as a benefit to automating beyond just cost from a labor standpoint?
Well, I mean, so obviously, obviously reducing the labor overhead is one piece.
Hmm.
The second is without having to um without having to add additional size, you can just turn up the machines to be able to go faster. So you're able to increase throughput through the exact same kind of machinery without dramatically increasing your footprint.
Right.
Another piece on automating is quality. I mean, I've been able to walk through the Ford Advanced Manufacturing facility quite a few times. And now all of these quality checks are all being done autonomously through vision systems. Well, robots don't really make mistakes like humans do. And so being able to really optimize for those quality is going to lead to better goods. I even think though, what's traditionally been hard in manufacturing is the idea of like customization. So I want a car to look like X, Y, and Z. Well, that's kind of been hard to execute mass on scale. But now with new tools and a lot more flexibility in the programming of machinery and options, we're now allowing for this mass customization on like a really hyper local level as well. So I think that there's a lot of things just driving that piece. To go back on the China thing, one of the biggest difference between China and the U.S. So I lived in Hong Kong for 3.5 years and speak Mandarin now very poorly. But you know, there's like a guy across the street of these factories who just like can make a machine like next week, and so there's this like very high technical level of just factory machine development all around these factory hubs. And I think that that's allowed them to iterate very quickly on their designs and very very quickly be able to like have a lower cost machine and be able to iterate on a lower cost machine, and then it gets perfected, and then it's like, okay, well, let's make it a lot better and spend the money, right? So maybe I buy a $5,000 machine, a $5,000 machine, and a $5,000 machine, and every time it's a little incremental better, and it's like, oh, I've got the perfect machine now. Let's just like really harden it. And so now I'm going to
Hmm.
spend 50,000 on that machine. But they were able to go through like 8 iteration cycles before in the US we were able to get a even, one machine, commissioned. So I think that's kind of an interesting little tidbit.
Yeah. Yeah. I think so too. And it's to me, the quality aspect is one of the things that is an incredible driver that we have today. And that leads me into talking about IIoT, the industrial Internet of Things. How does that play into the whole quality aspect?
Yeah. So, the traditional use case for IIoT has been a lot of predictive maintenance, which our company, is involved in for sure. Um, However, maintenance and reliability and quality are really two sides of the same coin. And so if you're poorly maintaining a machine, the reliability of that machine and the quality specs of that machine are going to degrade over time. And so it's important to have a quality system in place that also like links into the maintenance system so that we're able to execute things on the tolerances that we need them to execute on. Um, I believe that ultimately, increasing kind of these quality specs through a more robotic maintenance program that can be enabled by IIoT is really important. And I think that IoT being predictive of, hey, this machine is going to start have this problem. That problem is going to start causing quality issues before the vision systems pick them up. Will allow for better throughput from a facility perspective. Even as we were talking earlier, I also think that we've had different epics in manufacturing facilities, this idea of design for manufacturing, design for reliability, design for maintenance, design for safety. But I would say that I think that there's a new design for robotic maintenance coming up, and on a very large scale. And I think that IIoT is going to be the largest enablement of that technology.
Yeah, I agree, and it's interesting because if you talk to people that have been involved in the space program, one of their thought processes for going to Mars is more of a, well, what do you do when you land there? And if you have a robot that is handling getting there and then builds other robots from the resources available to it. So that's how do you go through that process of a robot maintaining a robot and maintain and being able to do the same types of things that you would ask a human being to do. And I think that if you start with that thought process of the end result, you start with the conclusion that we're going to have robots maintaining these machines. When you start with that in mind, then you can start thinking about, well, how do we go about doing it? If you don't think that way, you always are going to have this roadblock of preventing you from going to that area, thinking about it, and you always will find obstructions that keep you away from doing it. But I look at machines and I think about all the components that we have that go into them. Well, what is it that would prevent us? You know, I specifically can't think of anything that is so complicated that we couldn't have robots, machines handle some of that technology. What, where are some of the areas that you think that there'd be roadblocks in developing that?
So without using some sort of a large language model, I'm going to say a large natural environment model to be able to quickly assess each individual kind of use case and each individual like application. Right now you have one bolt oriented this way, another bolt oriented this way, and one bolt oriented that way. And the machine doesn't really know, the robot wouldn't really know where to take off each bolt in order to replace the piece, right? Um, have you started to see the new captchas? And the captchas are, they have a, they have a cup and it's angled, and you have to kind of point where what direction it's facing in.
Right.
Have you seen these? I mean,
Hmm.
so that's what they're trying to train though, is they're trying to train basically a version of an LLM, but in the natural world. I think a lot of it has to do with the full self-driving cars as well as probably Tesla's Optimus program. Um,
Sure.
so there's a lot of like there's very few areas in a facility that have enough scale that would be able to run training with the current compute powers. I do think though that that's changing quickly. And there's going to be enough vision happening in a facility and enough 3D models that can be put in from a machinery's perspective that there should be a machine that's going to be able to learn how to take apart a gearbox and put it back together again without a mass amount of human based training. There might still have to be a little bit of a human in the loop, but I think that that's really kind of the biggest hang up is just the lack of scale on some of the applications. You know, um, you have a paper machine, right? Well, how many paper machines in every paper facility? Like maybe two. You know, I mean,
Right,
so it's
right.
hard to train a robot on just two things. You need to have enough data and enough vision in order to be able to train it on a whole variety of things until we get to a much more kind of advanced compute power and resource. So
Yeah. And that kind of takes me into discussing about what is it that makes technology accessible nowadays? What do you see as far as the availability and being able to access technology that, maybe we didn't see, certainly probably not in the 80s or 90s, that those technologies were not readily accessible to the average person.
yeah, man. So where do we start? I mean, the accessibility of robotics. Look, we house a high school girls robotics team here at Grace, and I mean the little machines that they're building, and how easy the code sets are. Compute is all about layers of abstraction. So the more that we can abstract, the easier it gets for us to be able to interact with something, and the more specific that you can determine what the machine should do. And
Mhm.
so it's way easier to build these robots than it used to be. And if you kind of blow that up to a factory to deploy some cobot is now incredibly simple, much simpler than it used to be.
Mhm.
The other piece is maybe a little bit more nuanced. I think the rise of open APIs and protocols on the factory floor. It used to be we had all these things speaking different languages.
Yeah.
And I'm not saying it's not a problem today, but it's a fully solvable, continually solved problem. And so the ability to kind of like get these data sets to be able to build or develop a model on, eh, it used to be like this massive undertaking. And I think now there's enough technology in place to be able to take any sort of data in and get it into whatever format you need.
Yeah.
I think, I think another piece on the accessibility that's really um, uh, come in is we can model things before they ever physically happen. And so if we have a digital twin, we can fully model how that digital twin is going to interact. And so, I forget the name of the company that Amazon uses to model their warehouse and conveyor systems. I think it's yeah, don't quote me on it. But anyways, they're able to put workers in that facility and be able to test out in kind of virtual reality of how they're going to operate. Well, that's orders of magnitude less cost than building the entire facility and like screwing it up.
Right. Right.
And so those are kind of the three biggest things that I think. Did any others come to your mind that maybe missed the top of mine?
Well, I think along that same thought stream is, the ability to develop that digital twin gets married in a combination of things of AR and VR. We can model it and try and go through the problems and train on it in a virtual environment. And then as we move to a real environment using augmented reality to take us in another direction of being able to visualize what we actually see. We're seeing that, speaking of maintaining equipment, being able to put on a set of glasses or even holding up your phone, seeing a QR code on a valve, and it shows you how to take it apart and will connect you to somebody to troubleshoot it. And it will draw on the screen. This here, you have to press an Allen wrench in to pilot move this valve over. If it doesn't flow, then you know that you have to take the valve apart, and you have it. There's a lot more technology that we can incorporate. And to your point, I think the designing for that is the critical element. It isn't probably practical to go back to the 1930s and take equipment that was built in the 30s and say, take this, we want to design a robot to take this apart. It's probably not the most practical way to go about it. It's more realistic to say the machines we're building today, we want to make sure that the accessibility for a robotic end effector can access. And we want to use different types of bolts or screws that would be more accessible to
The
a robot
dexterity.
would make.
Yeah.
Yeah, exactly. So
Yeah.
I think absolutely in that same thought process, there is more and more opportunity there. And when you talk about technologies, the ability to get to a level like the Lego robots were,
Yeah.
where everything was just a drag and drop. You didn't have to really know programming. You could just drag and drop these little boxes which did different things. Maybe it was a timer, maybe it was a positional motor adjust for driving the servo. But I think that that same thought process is what's driven the accessibility today for cobots. The thing that's attractive to cobots is if I have to have a programmer, that's probably not the best solution for you.
Right.
But if an operator or just an average person with little or no programming experience can take that technology and be able to drag it and learn and teach a motion, teach a range of motion, you know, pick up the part here, drag it and move the arm over to this location, and now it has memorized that pattern, that range of motion. That in and of itself makes it so much easier than what we did 30 years ago when you had to sit down and get out your computer, your laptop, and program it in the every single parameter. You know, you think about even our regular computers, how much easier they were once graphical user interface became a reality on all the computers.
It's all about the abstraction. All about the abstraction for computers. I mean,
Yeah,
because we don't think in zeros and ones,
right,
and so for us, it's all about those making things that our minds have evolved over thousands of years to kind of be able to implement. Going back
right.
quick for the design for maintenance. Have you ever tried to change a battery in a Mercedes?
I have not.
There's certain German car manufacturers out there that they can learn a thing or two for design for maintenance, and it's have to take off 8 pieces in order to get to the battery under the seat, and it's like you're having to remove an entire thing. And but I do think that oftentimes we've been thinking more about getting a machine that meets the specs for performance, but not necessarily the spec for the reliability or the maintenance of that machine. And it'll be interesting to see uh, how the OEMs get their edge on probably having designing for this robotic maintenance. I think it's going to be a
Yeah,
really interesting evolution.
I, I agree because I can tell you right now that that was always a sore spot. Being I came out of the maintenance side of business at when I started my career, and engineers when they draw something on a piece of paper, they say, "Oh well, there's no wire from here to here." Oh well, there. Well, yeah, you drew that, but that's 300 feet away. You know, that's not practical to just do that. That's fine for from your standpoint when you're doing it on a drawing, but from a reality standpoint, that's not always the case. And a lot of times, engineers in car manufacturing, machinery manufacturing, they do it for the best way to do it for manufacturing that machine, but not for maintaining it. And I could tell you when I've had to take machines apart, I'm like, okay, how do I get to that valve? Well, yeah, you put it together when it was all apart. Now that it's together, you're asking me to take the whole thing apart in order to get to that screw that I can't get to now. So there's no question that we have to think in those terms, especially if we want to get to the point where we're using robots and technology to help us. We have to think in those terms and those end results, which we probably haven't done the best job of historically.
Well, how many companies have you run into that they care about obviously the lifespan of the equipment, right? And they care about the cost and the ongoing maintenance costs for the equipment. But how many in their rubric have a ease of maintenance?
Very
Or
few.
sorry, no, not their rubric, their scorecard when they
Yeah,
choose the machine manufacturer. And you're thinking about this in the future of just like, well, if we don't have people, it kind of becomes really critical that we're able to maintain this machine really easily.
couldn't agree more. I,
Yeah.
I'll tell you what, it's going to be, it's a fantastic opportunity though for the future.
Yeah,
I'm
I
looking forward to it.
and I think that not just the design, but also having the sensors in place on the IIoT front, right? I mean, so if you've got a vibration sensor on a motor, that will start to indicate if you need to go get it balanced. I mean, and so there's still a ton of both greenfield opportunities on the IIoT front, as well as existing brownfield applications that need to be sensed and monitored because you still have to have some sort of sensor, some sort of transducer to provide a signal to know that something is out of whack. And so I think that the whole IIoT space it still has a lot of maturity to go
Mhm.
before we can enable these things on mass scale. But it's happening. It's already here.
Yep.
It's just a question of how fast is the U.S. going to adapt? How fast are our companies going to adapt? How fast are we going to adapt? Um, you know, bef- you know, before it really takes over.
Yeah. Excellent point. Thank you so much, Drew, for being here today. We're out of time. Uh, Tell everybody how they can reach you.
Go ahead, connect with me on LinkedIn, Drew Allen, or go ahead and shoot us an email at drewa@gracetechnologies.com, and would love to chat with you guys.
Excellent. We really appreciate your taking the time with us today here at PMA and on the Destiny of Manufacturing. Everybody, make it a great day.